Okay, wow, something crazy is going on. Okay. Can you hear me okay, Dennis?
I can hear you. Yep.
Okay, cool. We're back on. You know what it was? Is I had the I had our YouTube channel open up in one of the tabs. So it was playing back live after, like an echo basically after I was speaking to you. So my apologies to everybody who's tuning in. Once again, we're here with Dennis, head of research from the Indexing Co. or Indexing Company, and so it's good to have you, man. Especially tuning in from the Netherlands, where we are headquartered. So I love that connection. And yeah,
Yeah.
man, I'm
Thank you for
hoping.
having me.
Of course, yeah, of course, yeah. I'm hoping we can start out. If you will tell us all a little bit about your background.
Yeah. So I'm Dennis, head of research at the Indexing Company. My actual background is in data analysis. So before I joined Web3 and crypto and started trading stuff like Ethereum, I was a data analyst in human resources and market research. And then I learned about crypto, did it on the side, did some trading, did some venture, did advise various DeFi projects with a group called DASXDAO. And I wanted to go back into data analysis, and I looked at all the data offerings basically, and I couldn't get the data that I needed. It was either you need like a full team of data engineers or um, yeah, big databases, spend a lot of money on pulling data from APIs, and none of it was actually what I was looking for. So then I started researching all these different solutions. And basically, that's when I met Brock. It's almost 2 years back now in Istanbul during Dev Connect. I pretended to be an investor, and he almost canceled on me too. But I learned about this solution, and I was like, hey, this is actually what's like ETL, and ETL is a term in data engineering that is about like extracting the data, transforming it, and making it usable for you as a data engineer. Like this kind of ETL we need in Web3. Um, so I asked Brock like, hey, can I work with you on this project? He said yes, and we're fast forward, we're here, and we actually have built good tooling for doing that ETL for Web3, and we're continuing to improve it. Um, and yeah, like I'm always researching stuff around how our tooling should look like, which chains to integrate, what our users and customers need, and like what kinds of data, because we can basically fetch anything from the chain. But how can we provide good tooling for them to understand what's going on, how they get that data, and how to make it usable for them?
So when you started with Brock, were you head of research or doing something different?
I no, I basically created my own title as head of research because I was
Nice.
doing all these different things, but in the essence, it was researching. Whether that was like researching with data on chain, researching our product, researching what is happening in crypto, because trying to pick up data from all these different sources, all these different chains, you need to know what's actually happening and what activity, where the activity is, and also what builders needs to grab that data. So um, yeah, it all is combined in a research role, um, and that's basically what I'm yeah what is at the core at what I'm doing at Index and
So
Co.
then on a day-to-day basis, as head of research, what does your day look like?
Yeah, that is a good question. Like a lot of that goes into talking to customers, seeing what kind of data they need for a product. So let's say it's an analytics solution and they want to verify like APRs on either like staking providers or just staking in general, or they want an APR on a DeFi pool, whether it's like on a lending market, for example, or in like a more difficult strategy that a DeFi protocol is is doing on chain. Well, and how do we get that data? And like which contracts are needed and which events are we looking for on chain? So that is a big part, helping them understand what data they need, setting up some pipelines for them. It's talking a lot internally because like we are the indexing company, but we are building a protocol that's called the neighborhood, and the neighborhood is basically the network that is processing the data. So there's a lot of research into the architecture that we're building with the neighborhood, how the product should look like, how to make that easy, so that actually nobody's really seeing what is happening in that network.
Yeah, so I definitely want to talk about the neighborhood in a minute. Before we get there, though, how did the name the indexing company come about?
Yeah, that is a good question. I think it just comes from the mentality of like let's keep things easy. Like we already are working on difficult tech. Why overcomplicate a brand? So it's what we do. There is a note that I have to make. Like in crypto, indexing is just like getting the on-chain data. Like that part is called indexing. But in general, indexing is a way broader term if you look at data engineering. And that's basically knowing where data is stored, like preparing it for easy retrieval. Like that whole process is what we're also focusing on with our products, because we flip the script a bit upside down versus what other indexers do. We actually build our own very stripped down indexers to retrieve data very fast, which then optimizes basically getting historical data, but also attaching new chains, and all of that, like you could call indexing. But it allows us like that data infrastructure to also go into non-Web3 data, or just Web3 adjacent data that's like not on chain. So we can, for example, index something like Farcaster, which before wasn't really a chain. Now they made it like it is, but before it was just like text data streaming. So that's what we're actually doing. Like we're indexing streaming data broader than just like on chain.
Uh, I have to admit, a lot of this stuff is over my head, so I'm enjoying the conversation for sure. Are you able to share a fun fact with us about your life, something outside of blockchain?
Outside of blockchain,
Sure.
that is well, this is my life. No, just kidding, just kidding. No, I
No,
like
I get it, man. It's workaholism, but it's not work because it's a passion and a hobby. Totally, I get that.
yeah, it's definitely fun. No, I always like analyzing stuff, or even there's some creativity in building products, and I like to be creative, so I like to make music or do photography.
Nice.
But it's all about creating something new. So yeah, I think that's also what I like about building a product.
So back to indexing data. So what's the core mission, the mission of the indexing company, and like what pain points in Web3 infrastructure are you solving, I guess, for the uneducated non-techie person like me?
Yeah. So um, let's start with the non-techie part, because like every user in crypto like sees data. So if you log on to Uniswap, for example, and you place a trade, you already see like pricing, and you also already see the the part where you place the trade, uh, something's happening on chain, and you get the data back, like, hey, your trade was confirmed. Like that whole part is already indexing. But between you placing that trade and the chain confirming that you placed that trade, there's a lot of stuff happening. So
Yes.
what we focus on is once you've like pushed buy, something is happening on chain, but your application doesn't know that. Your browser doesn't know that. So what these developers do is they need something that listens to the chain and then picks up your transaction. and that's the process of indexing. And there's a lot of data infra that basically then um, they listen to the chain. So let's say you do it on Ethereum. They listen to Ethereum. They then pull that into their own database. Then you have to listen into that database, like, hey, is this transaction happening? They then expose that through something called like an API, where then your front end can fetch that, and then you get it. And it's basically reselling data. And there's also other indexing networks where they onboard that data first onto the network. So you have to wait for confirmation there. Then it gets streamed to another database, and there's just like all these steps in between before it hits your front end. So a lot of times, if you're waiting for some confirmation on a chain, it is already confirmed on chain, but because of all that data infrastructure in between is actually slow, you're waiting on that. That caused a lot of latency. And
Hmm.
what we did is we stripped everything out of that, all these steps in between. So we just directly listen to a chain. That data goes into our network, but that network is like constantly streaming that data. So it's just listening to, hey, did this event happen? If so, take that data out and then even transform that data how our developer wants it or how they want to present it to the user. Um, so then you have all these steps basically in that one step, like, hey, listen for an event, transform it, and then push it forward. And that way we don't have to load all this data first into a database from all these chains, because then you have like a massive database with all these events. We just listen to the chain itself and then make it easy to filter and get exactly that data. Um, this is an example for just one transaction, but we can do that for a whole history of like um, let's say Aave. So Aave, there's a lot of like borrowing and lending activity. So now you want to know like, hey, how was that over time? How much like TVL is here? How much activity went through this pool? So then we have like tech where you can basically listen to the whole history of such a pool and then get that data really fast. And then from there, we can also deploy that same logic to new events that come in. So if then a new user deposits or like borrows funds, we start listening to those events too. And that way developers still use like the same data pipeline to process like historical data and real-time data too. So yeah, it has an impact on you as a user too.
So let's imagine you're in an office building, you walk into an elevator, and then a normal dude who's a trader walks into the elevator and he's talking about crypto, and then a developer for Web3 walks into the elevator also. So you've got a retail guy and you've got a dev. What's the elevator pitch when those guys are asking, what's the indexing company? What do you do?
Yeah, that's a good one. Yeah, so basically, what we do is just get you the on-chain data that you want. It's a different pitch for a developer, but the
That's
developer,
why I asked. Yeah.
yeah, saves a lot of like costs on their data infrastructure. They can develop faster, so they can push out products faster because they don't have to build all this data infrastructure themselves. And then for the end user, they just get better products because a lot of products in crypto resolve around data, so they can verify the APR better. They can see more analytics if they want to verify what's happening on chain. Um, and in some cases, the user actually sees less because the developer has better data to influence or make the experience more secure for the user. So that, yeah, that's a big thing in our offering, is that a lot of times we won't be talking to retail, or they don't have to care, because then we're doing our work right. If everything's working okay, nobody's complaining and nobody
Right.
knows we exist.
So we
Yeah.
maybe you can help me kind of parse out how it's different. So we run validators for a couple Cosmos oracles for Band protocol and for SATA protocol. Um, how, and I think Band is mostly like a pricing oracle, where SATA does like all kinds of information and makes that available for devs. If you're familiar with them, can you tell me how the indexing company is different from Oracle providers like them? And if not, maybe just kind of compare and contrast how indexing company is different from a typical Oracle provider.
Yeah, that is a good question to ask because in general, oracles put data on chain. So there is data that's off chain that has to be verified, and then you put it on chain so smart contracts can use that data. Indexing is actually on the other side of that, which then is like something is happening on chain, and then somebody has to pull out the data to see if that actually happened. Um, there is some synergies between indexers and oracles, because a lot of times oracles are aggregating, like for example, a price feed from different chains and then pushing that price back on chain. Like, hey, this is the current price on let's say Ethereum for one ether, and then you could push that to Solana and let Solana know, like, hey, here's some Ethereum. Like this is the value of one ether basically. So that way you're both like indexing and doing an oracle. So we, like, if you for example look at the CETA documentation, there are indexers and data providers on CETA
And
that can push data towards the oracles, and then you can be part of an oracle pipeline. But in general, uh, yeah, Oracle puts data on chain, Indexer pulls it off chain. But if on chain data is needed to update an Oracle, you get like a bit of a circle where data from one chain gets updated on another chain. And it gets even funnier because we can even index an Oracle servers, like if they're still pushing data and when they're pushing data. So it's might also be like monitoring if like an Oracle is still online. Like that could happen too.
so on Indexing Co's website, there are kind of like three bullet points where it says filter, transform, deliver. And it's kind of like track addresses and contracts and track events, transform that data into how you need it, and then deliver it, I guess, to the end user. Or I don't know. Are you able to distill those three things, that process down into something the average person can understand?
Yeah, yeah, absolutely. So what we're basically listening to when we want to index something on chain is just like a block of data comes in. So every time chain keeps running, a new block is produced, and that block contains like all data at once. But if you're interested in only a Uniswap trade, for example, you have to filter out only the Uniswap trades, and you can like ignore the rest. So that's the filtering step. We take a look at, hey, is this event related to Uniswap? And Uniswap emits events that say like, hey, yes, this is a swap. So um, it is always encoded data on chain. So it doesn't say like swap directly. It has like a whole signature, like a string that you have to pick out. But we can detect that event. So essentially, we could listen to a Uniswap swap that says like, hey, this is the event swap. That is the filtering part. But we can also filter on a contract. So if we want to listen to a specific Uniswap pool, there's like trades going through this contract um, that routes all these trades. But then there's also like a pool contract that's like, hey, you have to interact with this pool because that is, for example, ETH USDC pool. So there's a lot of filtering going on where we say, like, yes, this is Uniswap swap. It might be this pool that we're interested in. And we could even filter further when we want to say, like, hey, I want your wallet address. Where it's like, hey, I want your wallet address specifically for this pool, and I just want all your trades from the past. Well, then you have like a combination of all these filters. From there, you basically just have the raw data, but maybe you're only interested in which coin went in and which coin went out and how much from these coins. You're not interested in like in what block it happened, or you might not be interested in um, um, you might be very interested in the time. So then you can add the time to that. You can even transform that time where it's like, hey, I want to make it human readable instead of like just a timestamp, which is often not interpretable by humans. You can do these transformations. You can even do some calculations between that. So we could, for example, in a block, like each USDC is tied to USD pricing. But if I have like ETH in a pool and there's some meme coin, I don't know the USD pricing. So we could also like add USD pricing as a transformation there. And from there, you can send it forward. And this is where a lot of indexers lack the um, basically the flexibility, and they just write it to a database like they know or control. But we figured out like, yeah, you want it in your own environment anyway, your own database, your own front ends, and like your own back end. So why not write to that directly? So we build a lot of connectors so we can attach it, like send that data directly to our developers that are using our deck. So
So
yeah.
if I'm so I come from TradFi. I don't. I love computers. I love technology, and I know enough to have a dangerous conversation with someone who knows nothing. But obviously, compared to someone like you, I don't know what I'm talking about. But I know a lot about economics and investments and that kind of stuff. So if I'm a developer, and I get what you're saying, that you're going out there and you guys are grabbing whatever information is important to me as a developer from my app. But and then you guys relay, I don't know if relay is the correct word, but you then send that information to me to host in my own backend, my own database, and then to manipulate on my own front end. Is that correct?
Um, yeah, it's mostly you manipulate it actually in your backend eventually, but it's yeah, that is correct. But you can
Do you
of
guys
course,
offer
yeah.
like, do you have like a, so when I say manipulated on the front end, I guess I'm thinking of like Windows, because I look at command line stuff in Linux and my eyes glaze over, and I'm doing my best to learn it, but it's just it doesn't come naturally to me. It's like learning a foreign language. So Windows makes sense, right? Where I'm moving something from one folder to another, and so that's why I say manipulate it on the front end. So I think I'm
Yeah,
using
yeah.
the wrong terminology. But if I'm let's just say I'm a beginning dev, I don't have any of the front end stuff. Does the indexing company offer, like, is there a platform where I can log in and manipulate the data, or it's all like a feed that just comes out to me and it's up to me to have the front and the back?
Yeah, that's correct. Like we have a little front end where you can test like the transformation code and basically build your feed, like how that looks like. Um, but then eventually we will ask you like, hey, where does that data have to end up? Because we're not storing that. Like you want that data, so you can store that in your database. And
So that's where
basically,
you guys, so that's where you say on your website, stop duct taping APIs and subgraphs and stream it to your own database, basically.
yeah, like you design the data feed exactly how you want, so you don't have to fetch it from like four parties and then also do these transformations and figure that out. Like, yeah, you have just one feed, that's your solution to this, and now you can work in your own database and your own environment. And basically, if you have to compare it to maybe tooling that is more familiar, it's like your database is just a very complex Excel sheet,
Right.
and now you can start manipulating the data, looking it up, searching for that data, and from there you expose that to your front end so your user can actually see that. But there's a lot of like analytic solutions to orders, that want to build charts, so then you have to like aggregate data, like take the sum of like all these transactions and then put it in a chart. Or there is a trading firm that doesn't use a front end but uses this data stream to make trading decisions. So let's say they're arbitraging between Ethereum and Optimism, and they see like, hey, the last trade on Ethereum was a few dollars higher than on Optimism. Well, now we can arbitrage that, right? Like, hey, let's put in a trade on, like, sell it on Ethereum and buy it on Optimism, because we can make that decision because we have that data now. So it's not only about like presenting data; it's also about triggers. triggers on that data. Maybe an example for maybe a single user is like if you have your funds in a pool and you want to make sure that there's enough TVL, or you want to track activity. So if somebody starts like pulling out like millions on that pool, you could design like a data pipeline that says, hey, if somebody's pulling at least $1 million of USDC out of this pool, I want to know that. And then you can just design a pipeline that alerts you with specifically this pool filtered and specifically the filter on the value of like that's being pulled out.
So yes, I love making connections between like people, and we like I said we run a validator for SATA, and then we also run one for Intento, and Intento does triggered on-chain actions like if this then that, and so I'm getting a little bit ahead of myself because I would like to talk about collaboration opportunities and who you guys are interested in meeting, but this is where the conversation is. So, a company like Intento that allows people to set up triggered transactions, would they be a good um, would they be a good fit to stream data from the indexing co, or for you guys to know them because those triggers could pull whatever on-chain data the end user wants Intento to set the trigger for? Does that make sense?
Yeah. I think something like that would be ideal. Two ways where that can actually so funny enough, we could be before Intento like does something or after. So the before is um uh, like looking back at the example I just gave, like hey, I maybe I want to listen to Ethereum hitting like let's say 5K in the next few weeks, hopefully.
Okay.
Um, then we could index like Ethereum use like USD pools and see if that pricing is reached. And then once that reached, you can um, create a trigger, like do something on chain. So that could like be an input for these triggers.
Okay.
And then after a trigger happens, like if to do something is on chain is like, hey, send an Ethereum transaction off because I'm holding Ethereum, but like at exactly 5K, I want to sell that. Then hopefully like Nintendo triggers that, but then like you have to listen to that transaction on chain. Like did it happen? Like was this action actually executed, and then report that back to the user, whether that's like through their interface or through an email or through a message. Like that part we could index to. So yeah, it's a bit of the combination of like controlling the data flows from what's happening on chain. But yes, I think that's a good example.
Yeah, no, I'm also so we are our back end developer is currently building a dashboard for our delegators, and it's going to allow them to have a much more detailed look at their staking activities, both with us and other validators, and they can swap and a lot of on-chain stuff, but also some off-chain stuff like news. And then I'm thinking, I don't know, like would our back-end developer um, use flows of information and data feeds from the indexing co, or are you guys more complicated than what I'm talking about for like our delegator dashboard?
No, it's actually a perfect fit, and we've built cases like this also for like staking and validator services. So one of
Awesome.
the problems like these providers and like custody providers often have in yield is they need to get all the transactions from these pools. Sorry, from these nodes, but especially they have to do reporting on like how much yield is being generated. And the funny thing is like every time it's being accrued to your wallet, that's an on-chain event, so we can just pick that up. And then you can present it in the dashboard. You can have reporting for taxes, for example.
Oh, that's big.
Um, yeah. So, and then actually, the only thing we have to do is listen to the transactions from the wallet or the contract where it's being staked and where these values accrue. I literally have heard of examples where even big staking providers just go on block explorers every day and see how much value they accrued, which is like manual work. But we can basically just automate that and like give you that data, and you can, you know, build a nice dashboard. You can do automated reporting based on that. So yeah,
I love it. I
it's
love it.
it's exactly something that's like business intelligence does in Web 2, and like banks do, like um, yield accrues, or you, if you have a bank account, there is like interest, like that accrues, like that accrues every, that you could literally do that every minute. um, you can do it in crypto on every block that hits, or
Sure.
every time that event emits that says like, hey, you got a reward. Yeah, and that's where we would come in and pick that event up and give you that data, like, hey, this happened on chain. So
I
um,
love it. I'm
yeah.
excited to introduce you to Fidel, our back end dev. So then,
Cool. Yeah.
okay. So what are some of the most exciting use cases that you've seen so far?
Yeah, it's like, so far I talked in this stream about like very small use case, like pick up a single transaction or pick up some rewards, and that's actually very low volume for us, because we just listen to that event. If it hits, yeah, we'll process it for you. But where it gets exciting is actually doing this at a massive scale. So we've done, for example, we worked with Once Upon last year, and they did a block explorer for all these like optimism chains, and we were doing data infra for at least 20 chains simultaneously. And then there was an enrichment in that data where we would pull in like data from Farcaster, and then you have like 20 chains at the same time producing all these blocks coming in, and like that's like data infra like at scale. um, but that's also like, it could be in like a single customer, but we also do it for multiple customers at the same time. So now we're actually tracking at the same time more than 120 chains at this moment. But we can add any chain whenever somebody needs it for their use case. So it's not only data at scale, but also being flexible, like staying flexible at scale. So yeah, that's basically why we built the neighborhoods. And under the tech under the hood is basically a network that just processes and streams data, and we're tapping into the potential of Web3, where the data is already open, which is like open chains, openly verifiable. Um, but what we can do is also start breaking open like other data sources, so like databases from users that want to expose that. And normally, you would have to expose another API, and then um, have others integrate that API. But what we want to do is make sure this network can process that data too, and then you can start adding stuff like, hey, let's add on-chain data with off-chain data. So let's say we're streaming stuff on Twitter, and somebody's mentioning um, a coin on Twitter and tagging that. Well, now we have data about that coin too, which is not really on chain, but it's related to the activity of that project of that coin. And now we can actually start matching that with on-chain data too. So, you
Sure.
know, there is stuff where you can combine the sentiment with the actual price action of a coin. And I think that's what we're moving towards, where we're saying like, hey, we have this network that's processing all this data on chain, but let's start adding data around Web3 too. Um, and
So like I
that's
guess because the amount of data is endless, right? And the more you're
yeah.
telling me, the more I'm like, holy shit, this is like pretty amazing. How in the world do you guys ensure scalability when the amount of data is infinite?
Yeah, and that is the problem we're solving here, because to remind you, like all other data providers first onboard data into their own database or their own network. So now you have another copy, which doesn't scale because the amount of data is infinite. Like
Makes
we
sense. Sure.
like there's every new day new chains there, and all on every chain there's more and more data. So as you're correct, like it is an infinite data problem. So what we try to do is we build a good processing layer that filters that data and just gets it from where it is. But our network is just a processing network. So our net, and this comes back to why we're called the indexing company. We index where the data lives, so we can fetch it whenever we need it, and then we can just fetch it on the fly whenever that data is needed at the source. But to do that, we basically need to have a lot of processing power in our network. And that is the secret to the network. It's a lot of like small nodes that coordinate all together to fetch that data from where it's needed. And then because that network has all these small nodes, you have to cut up the data in small pieces. And that's where that coordination is super important. The other secret there is that these nodes are so small that we could also, for example, run them in your browser.
I was just about to ask, so can the average person run a node on their cell phone?
Yeah, exactly. Like that could be possible. So we're not there yet, but these nodes are so small that that could be possible. So let's imagine you're visiting Twitter. The moment you're visiting Twitter, you're just loading a website. They send you a feed of data. That's basically your feed tailored to you. But there's a lot of stuff happening on the back end that's calculating like what's your next tweet and fetching it from somewhere. What is needed for that is like these massive data centers that just run a lot of compute to process all of that data, while your computer essentially or your phone is only working for like, let's say 20 to maximum 40%. So that's a lot of compute that is actually unused while it's still there. Or even you as a validator, you run a validator, but that has like a lot of excess compute in that server you're running it for, or the computer you're running it for. So we want our nodes to live next to that validator node, next, like in your browser, on your computer. So now you're actually helping the company process the data, and they can reward you for that. Or
What is the reward? How does the indexing company reward people who run nodes? Like what's in it for me, Dennis?
yeah, very very important. So let's say you're a validator and you're validating transactions on a network like Ethereum. Now you are running these, like you're validating these nodes, but next to that you have access compute. So you install like a neighborhood node, and now the neighborhoods can give you jobs like, hey, somebody's actually asking you for Ethereum data. Here's a block of Ethereum data. You process that and send that processed data back. But it doesn't have to be Ethereum. Like you can literally run an Ethereum validator and then process the data next to it from Arbitrum or Optimism. It's just like if you have the access compute, like that's what the node is signaling, like, hey, there's a computer that you can tap into. Then the network says like, hey, yeah, our data consumer, our developer is interested in a data stream. Here's a block. You process it and you send it through the network to that developer. And then you can like do that in parallel. It's not only you as a validator, but it's you as a validator with like hundreds of other validators that just get some additional jobs to make sure that that compute is well optimized and actually used. And now you can get paid by the network because you're doing a job. And you get paid because you're doing that task instead of like a huge Google Cloud provider that is like selling you these massive data centers, because the compute exists and it's a resource that we're just not tapping into yet.
So let's talk about, you mentioned the neighborhood, right? And
Yeah.
I think it's a really cool concept. The neighborhood is developers or chains or nodes, or can you tell us, what is the neighborhood? How does it grow? How does somebody tap into it? What purpose does it serve? All that sort of stuff.
Yeah. So the neighborhood is basically a data processing network that has it's a three-sided marketplace.
And this is
So
a protocol you said that is going to be,
yeah,
it's a protocol or no?
Yes, it's a protocol, but yeah, we're building it as an Avalanche L1.
Oh, that
But
was my next question is
interest
where is it going to live? Yeah. Okay.
yeah, we're building it as an Avalanche L1, and it's not really a chain you would deposit funds on. It's more of a coordination layer between the nodes that just processes these tasks. But the great thing about that is you as a data consumer could come in, like a developer that needs data from a chain or needs data from Twitter, or they can come in and request that from the network. On the other side, you have two parties, and one is like the compute provider. So that's the access compute that I just talked about. Like people can contribute with their compute. Um, and then we have data providers. So there's also data providers. Right now, that's just the chains, like the RPCs from the chains. Those give you the blocks from the chains that are coming in. So that's a data provider. But that could also be a company in crypto that wants to expose, like, hey, we're doing a lot of research on what trades are like wash trading. Like that's a valuable data set. They could provide that data too. Or a security company that says, like, hey, these transactions, like we'll mark this wallet, this is a hacker. So all these transactions, that is like, you should not like take them in as like a centralized exchange, for example. So now they can resell that data to the network so that you can subscribe to that data and say, like, hey, this is not like, this is data I'm interested in. Like I don't want to deal with this transaction, or I think this transaction is like extra valuable because it's coming from these sources. And now you have like this three-sided marketplace that is just using the network to get the data from basically A to B. It is an Avalanche L1 under the hood, but funny enough, we can have actually somebody saying, like, hey, I want to pay on Ethereum for this job. Well, just send us a transaction to this contract, and now you're paying for this job that's being triggered on Avalanche. So there's yes, it is a separate network, but we tap into basically any other network in crypto because we can use them for payments, or we can use those validators for excess compute, or we can process their data. Like that's what we're already doing actually. So
So how did you guys choose Avalanche over, are they called supernets on Avalanche, or is that what they used to be called? I can't remember.
yeah, they were called subnets, but now
Subnets, right?
yeah, but it's they subnets developed into just Avalanche L1s. Like so,
Gotcha.
there's various Avalanche L1s, and they
Yeah, we
all
we ran an
integrate
Avalanche
together.
validator for a while and it wasn't profitable, and so we shut it down, which was such a bummer. Because I
Yeah,
totally believe in the Avalanche ecosystem. It's blazing fast. The team is reputable, and I think they're here to stay. So we were bummed that we shut down the validator because we had high hopes for it. But why did you guys choose Avalanche? If you want your own L1 over something like Cosmos, where you have the flexibility to have your own validator set and just more sovereignty.
yeah. Well, that is what's happening now with these subnets and L1s and Avalanche. You can have your own like validators. You can have your own um, like other nodes. So we need flexibility around that because it's not only like a validator, it's also just smaller nodes. So we'll have various styles of nodes in this network. So some are processing data; those are the small ones. Then we have like validators slash coordinators that basically say, like, hey, these job, like this customer wants this data set that contains like 1,000 blocks, and there's 1,000 nodes in parallel processing the data. I have to coordinate that and get the data, validate if everything is in here, and then we push it through. That kind of stuff, like that flexibility, is what Avalanche actually gives us. I think what they improved with the L1s, and I'm not fully sure on this, is that you can actually have a validator for Avalanche itself and also validate at the same time other L1s. I think that is some shared security that they're doing now. So it might
Gotcha.
be in the past that there weren't enough networks for you to validate. It might be now, but I can't fully um, tell you that. I think one of the
Gotcha.
problems with just in general with a lot of networks and crypto is that they're not profitable because they lean into just emissions from the token itself, and then the token goes down, and then suddenly you're looking at emissions that are valueless, basically, and it's not profitable. So that's what we're actually seeing with a few indexing networks at the moment. They need that start problem where they have to sell a token and then just give these indexers a token, but it's not actually backed by value. We're flipping
So
that
is
script around.
so
Yeah.
is Avalanche the ecosystem that you guys have the largest presence in and most active in, or are you guys? Am I incorrect in thinking that?
Yeah, funny enough, not. We're actually mostly indexing a lot of like EVM chains, like mostly on stuff like Ethereum and Base, and we even do Solana. But now that Avalanche is expanding, it took a while for these L1s to land. We are going to index way more in the Avalanche ecosystem. So that's, I think, something that we're rolling out in the next few months, that we're planning to do more indexing on Avalanche. But we're indexing Avalanche, the C chain already. I think at least 2 or 3 Avalanche L1s, but there's way more that we can index there and provide enough.
And so
Yeah.
does your role differ on Aptos to Polygon to Cosmos to Avalanche, or is it kind of the same just across ecosystems?
It is the same. Well, funny enough, a lot of indexers just focus on one ecosystem of one type of data, but
Yeah,
they
no,
have to, because they have to put that into their database and their known structure. Um,
gotcha.
and because we are very data agnostic, we just look at the data as it is, and then we focus on that filtering layer and the transformation layer. We actually can process any kind of chain data, and we'll just from there, we just have to build some better templates that process that data better, but we don't really care how the data looks like when it comes in. So that's why we can index all these different chains, because we're agnostic in what kind of data or what kind of like virtual machine the chain is running on. And that makes it also flexible, but it's also the proof that we can process like any kind of data later on. So that's what we do with Farcaster. That's what we're going to
So
do with.
do you guys have
Yeah.
plans for a token at any point, or is that just an unnecessary layer of complexity?
We're definitely thinking about that, because we need to process like those transactions, right? So what I talked about with the problems with these other indexers and indexing networks, like they needed a token to just emit value and hopefully keep those indexers alive. Basically, what you ran into with this validator, it wasn't profitable. Well, um, one fix for that is actually tying the token to actual usage, and actually the token that's in circulation is
On
based
utility,
on
gotcha.
the actual utility. So then we can even let like customers just pay in USD or pays in stable coins, and then automatically swap that to a token. And then that token, is the way to transact value through the network, and then basically pay the people who provided the data and provided that compute. And there's so much stuff possible already that you could even swap the token back to stablecoins. It's just like you could have a token as the accounting mechanism, and that's what we're actually planning to do, where the network will need a way to transact value, and then you can insert a token, but it has to be sustainable, and it
Right.
has to tie into the actual usage. But we have actual users. It's we don't have to incentivize it. So that's why we're also not rolling out the network directly to everybody who can provide compute. We're actually saying like, hey, this is probably the compute that's needed in the network. Let's assign that, so that these nodes can actually get paid for the actual work they do. And if they're not, they're just idle and just not tapping into that compute. But we want
So
to tap into that resource. Yeah.
okay, I love it. In terms of collaboration, what types of projects or protocols would be great to collaborate with, and are there any specific projects or teams who you guys would really like to work with?
Yeah. Well, essentially, it's anybody who is interested in and needs on-chain data. So that could be
All
any.
devs then.
all developers, any like DApp, any analytics solution, any like wallets. There is like multi-chain solutions that definitely can't run all this data infrastructure in house anymore. Like that's when we come in. But yeah, and there's like chains. We're very interested in working with the chains directly because they know their developers best, but also because we're rolling out the neighborhood right now. We want to know like, hey, do you want to provide extra yield to your validators? um, because yeah, as you said, like maybe it's not just profitable alone to run that chain. Well, if you then incorporate the neighborhood nodes next to that,
Right.
maybe it is that. So now you have additional yields around your chain.
So is that kind of like we run an
Yeah,
AVAX validator, but then we have a bunch of neighborhood nodes as like sidecars, basically?
yeah, in like the same infra, and then you can get paid for that processing too. So then
Interesting.
you run a validator. You validate transactions on Avalanche, but you're also processing data from different chains. But it could be processing data from Avalanche itself. So that's where the synergy is with a lot of chains. Like we don't want to only take data from the chain. We could use the infra from the chain itself to process the data better too.
So if I'm a dev, or maybe better, what's the best place for developers to get support? How do they get started? Where do they find the documentation? That kind of stuff.
Yeah, so basically we just have the website indexing.co.
I'll throw that up on the
If
screen there.
yeah, thank you. And if you add docs, docs dots before indexing co, you have like docs.indexing co. Then you have our documentation. So if you want to test our tech out, reach out to us. It's hello@indexing.co. And then we can provide you with an API key. We're also working on a portal where you can just sign up and you get the API key, and you always get some free indexing credits. So you can just like test out a few pipelines, you insert a few contracts, or you insert a few events you're interested in, and then start streaming so you can see the whole flow work, and then we can build it out from there with you. So yeah, you can also reach out to me on Twitter. It's aperture, and APE underscore RTURE. You can always DM me if you have questions. Yeah, those are all the ways to reach out and have discussions with us. Happy to think with you on how the actual solution looks like, how your data stream looks like, where to deliver that. So,
Did I get
um,
your correct on the screen there? Is that your correct Twitter handle?
absolutely, yeah, that's me.
Okay. I tried to keep up with what you were saying. So
Yeah,
what is next on the roadmap for you guys?
yeah. So we are very actively developing the neighborhood. So that is on the roadmap. We're racing around right now. So if there's any investors in the crowd listening, um, feel free to reach out and get our seed round details. We're going to use that to build out the neighborhood. It's about developing these nodes further. Like we run the network already internally. We have it running for customers, like 80 projects we support already in the last 2 years. But now we want to open that up so others can run these nodes, like the validators. We want to service the chains better. And that's how we actually expand the neighborhood itself.
Yeah, man, I'm
Um,
excited that we met. I'm excited to introduce you to Eric, who runs our tech. I do all the kind of the front stuff. And
nice.
I
Yeah.
we'd love to support you guys. And one of the things I love about doing these conversations is that we usually wind up supporting the folks we chat with. And so I think this is just awesome, Dennis. I appreciate you, man.
Yeah. Yeah. Thank you for having me and like reaching out to me to have me jump on this stream.
Yeah, well, I tell you
Definitely.
what, let's end with I love to do a speed round just to keep things interesting. So let's go for this. So I'm just gonna list two words and then whatever comes to mind first, shout it out, okay?
Awesome. Yeah. Let's go.
How about Coke or Pepsi?
Coke. Yeah.
Coffee or tea?
Ooh, yerba mate tea.
Cats or dogs?
Dogs.
Call or text?
Text.
Netflix or YouTube?
YouTube. Yeah.
Yeah, I'm the same way. Pizza or burger?
Burger.
Physical book or ebook?
Ooh, the feeling of the book itself is really nice. Yeah.
Yeah, I'm the same way. I like to underline. Action or comedy?
Comedy.
Which, by the way, if you've not seen Happy Gilmore 2, we just watched it yesterday and it's hilarious on Netflix. Um,
Okay, nice.
rock and roll or hip hop?
Rock and roll. Yeah, I'm a guitar player, so
Morning person or night owl?
night owl for sure.
Sitting on the beach or camping in the mountains?
Uh, I don't the camping probably camping.
Big party or small get together?
Um, Small get together that like gets out of hand. We'll make the party out of get together.
And then finally, road trip with friends or romantic getaway with significant other?
Road trip for sure. Yeah,
Nice, dude.
get some adventure
Uh,
in.
well, cool, man. Well, we're coming up on an hour, so I'll let you go. For everybody who's listening, we provide validators on all kinds of different chains, Superactive and Cosmos, and we're offering an Atom promotion right now where we're rebating commission for up to 5 years. But we also run Polygon validators and Avail and Radix, and so please check out our website to stake some tokens with us. And then also go to indexing.co to learn more about the indexing company and certainly reach out to Dennis on X. And right on, man. I appreciate you so much. I'll end the stream, but if you'll hang in there, I'd love to bullshit with you for a minute or two before I let you go.
Absolutely, yeah. Thank you for having me on the stream.